Good morning, class. Today we're going to step away from motion to talk about energy. What is energy? Well, energy is the ability to move. Okay, I was actually lying. We're always going to be talking about motion when we're in physics because everything comes down to how things move. So energy is the ability to move or to be ready to move. And energy tends to come into two big categories. We talk about potential energy, where potential energy is the stored ability or to be moving. So an example of this would be when somebody is coiled tightly, ready to go for a sprint. They have a whole bunch of energy that's ready for movement, but they're not using it yet. The other type of energy that we talk about is kinetic energy. And this is movement energy. How much is something moving? That's a question of kinetic energy. One thing for us to note here is that energy is a scalar value. And hopefully you remember here that scalars don't have any directions. Now, the unit of energy is measured in joules. How big is 1 joule? Well, if you had a 1 kilogram mass traveling 1 meter every second, it would have 1 joule of kinetic energy. Or if you took 1 kilogram of mass and you lifted it about 10 centimeters off the floor, that is 1 joule of gravitational potential energy. Now, how do we calculate energy? Well, let's start with the easy one, talking about kinetic energy, stuff that's moving. And let's just have a couple questions to help us understand. What would have more energy when it's moving? The same speed. Would a baseball have more energy or a bowling ball? I suspect you guys would say that a bowling ball has more energy. And what it just means here is that more mass would mean more energy. Well, what about this different situation? What if we had two bowling balls? One was traveling really fast and one was traveling really slow. Which one has more energy? The fast one. And this kind of goes ahead and says that the more velocity you have, or the more speed, since we're talking about scalars, that just means you get more energy. So we know our formula for kinetic energy is going to have to relate to both the mass and the speed. The formula we have is 1/2 multiplied by the mass multiplied by the speed squared. In both of these, if we increase the mass, increase the speed, we get more energy. This formula works with the sort of things that this formula works with the way that we think about the world. Now, the only type of potential energy we're going to talk about is gravitational potential energy. And this is the potential energy that comes when you're holding something up. When you hold something off of the ground, there is potential energy because the moment you let it go, that potential energy can turn into kinetic energy of the object falling. The moment you let it go, it turns into that kinetic energy and turns into movement. So holding something elevated above the ground is storing energy that can become motion. So let's just consider this potential energy of our key situations. Which would have more potential energy when they're held the same height, a baseball or a bowling ball? Hopefully you say a bowling ball, because just like kinetic energy, more mass means more energy. Now, what if you took two bowling balls? One you had held 10 meters above the ground, the other you held only 1 meter above the ground. Which one do you think has more energy? The higher one. And this just means more height means more energy. And hopefully that all makes sense to you. So we have a simple formula here to help us calculate gravitational potential energy. Potential energy is equal to the mass of an object multiplied by g. G is the acceleration caused by gravity. Its value is 9.8 meters per second squared, multiplied by h. H is the height. Let's try working with these with some examples. A 350-gram soccer ball is kicked and rolls at a velocity of 7.5 meters per second. What form of energy does it have? Well, we're talking about a moving soccer ball, so that means we're talking about kinetic energy. So we're going to use our kinetic energy formula to calculate this. This is 1/2 times by the mass times the speed squared. Now, one little thing, before you go ahead and plug in 350, you always need to turn things into kilograms, meters, and seconds. So 350 grams is actually 0.350 kilograms. Now we can do this. 1/2 times 0.350 times 7.5 squared. Remember to use BEDMAS. You have to do the exponent first before you do your multiplication. I get approximately 9.8 joules of energy. What about this second example? A car is hoisted 1.8 meters above the ground for a mechanic. This car was lifted upward. When things are getting lifted upward, we are talking about potential gravitational energy. So let's calculate the energy using the potential energy formula we made earlier. M times G times H. The mass is in kilograms, so that's good, 1,400, times G, we just have to remember that G is 9.8, times the height, 1.8. Let's go ahead and punch it into our calculator. That's pretty big. That rounds to approximately 25,000 joules. One last one here. There's a 1.2 kilogram shot put and it's thrown at 3 meters per second and it flies 1 meter above the ground. What type of energy does this have? Well, it's moving, so it has kinetic energy. But it's flying above the ground, so that also has potential energy. It has both kinetic and potential. So how do we calculate the energy? Well, you calculate the amount of kinetic energy, 1/2 times m times the speed squared. .4 joules for kinetic energy, and you also calculate the potential energy, the mass times the acceleration due to gravity times the height. In other words, 1.2 times 9.8 times the height of 1 meter. That's 11.76 joules. And to find the energy, add the two. So that will add to 17.16 joules, or that rounds to 17 joules of energy in total. Hopefully this made sense. Have a good day.